Okay, one way of defining this, the permutation of n things taken k at a time, is just by saying, well, it's n, that number, times n minus 1 times n minus 2. And how far down do we have to go? Remember, it's not n minus k, but it's n minus k plus 1. And if you counted them up, well, I guess I left off the multiplication symbols. I could have just written them right next to each other. Times and times. We're multiplying all these numbers together. N times n minus 1 times n minus 2 times blah, 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 all the way to the end. And if you count up these factors, there would be exactly k of them. So, and yeah, very important. N is always greater than or equal to k. You will never see something like P8, 9. No way. This number k is no bigger than n. Okay, so k will be less than or equal to n. All right, a very important definition that we're going to use very, very much is the product of integers n all the way down to 1. So what I mean by that is n minus 1, n minus 2, all the way down to 3, 2, 1, is denoted n with an exclamation point. That exclamation point, we read that as n factorial. Okay? So, before I write this one out, let me just do a simple example here. What do you think 5 factorial is equal to? 5 times 4 times 3 times 2 times 1. The times 1 never contributes anything, but I almost always write it down. So since that's such a small number, I'll go ahead and figure it out. 5 times 4 is 20. 3 times 2 is 6. 20 times 6 is 120. So the number 5 factorial is 120. So n factorial would simply be n, actually exactly what I wrote right here. N times n minus 1, the next number down, times the next number down, all the way down to 3, 2, 1. 3, 2, 1. That's the definition of n factorial. The numbers get very, very big, and we're going to be dealing with fractions. But please don't let that worry you. Fractions with factorials on the top and the bottom are very easy to work with, and we'll see. Okay, some special cases. What do you think 1 factorial is? Well, if n is a 1, you're already there at 1. 1 factorial is simply 1. This is the one you need to memorize. If this were not the case, nothing would work. 0 factorial is defined to be 1. It makes everything work. So 0 factorial and 1 factorial both have the value 1. And it says here, this is only defined for numbers from 0, 1, 2, 3 whole numbers, no positive integers for factorials. All right, so just for practice, let's find n factorial for all these values of n. Well, we already saw that 0 factorial is equal to 1. That's just by definition. Okay? It doesn't make sense to plug it into the formula. Just memorize that. We also know that 1 factorial is equal to 1. Well, 2 factorial is equal to 2 times 1. I'm just going to write 2. 3 factorial is equal to 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. It starts getting big very quickly. Let's see, 5 factorial we already did. We wrote that out up here. It's 120. So one note I want to make with this example is, let me say if I were to write, actually I want to write 5 factorial out. It's 5 times 4 times 3 times 2 times 1. Sometimes I put the multiplication symbols in them, sometimes I put a dot, sometimes I put them in parentheses. Now, what can you tell me about this group that I put in the square brackets? What's that equal to? What is 4 times 3 times 2 times 1? Isn't that 4 factorial? So 5 factorial is equal to 5 times 4 factorial. That makes sense, because 5 is just the number 5, and 4 takes you from 4 all the way down to 1. So if we remember this, it'll make some of the problems easier for us to do. Okay, let's work with some fractions. We're going to be dealing with these quite a bit, especially when we get into probability. So, what do you think 7 factorial over 6 factorial is? For this one, maybe I'm going to write it out. 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 6 times 5 times 4 times 3 times 2 times 1. Let me put a wall there between those two problems. Okay, well, what cancels out? The 6, 5, 4, 3, 2, and 1. That's equal to 7. Remember what I said up here? Isn't it true that 7 factorial is equal to 7 times 6 factorial? Well, if I put 7 factorial over 6 factorial on both sides, that's what we're looking for, 7 factorial over 6 factorial. The 6 factorial over 6 factorial cancels out, and it leaves us with 7. Now, before we move on to the next ones, I want to just make sure you're positive about this. 10 factorial over 5 factorial. You cannot cancel this and say that's equal to 2 factorial. Absolutely not. It would be 10 times 9 times 8 times 7 times 6, and I could just continue that with 5 factorial over 5 factorial. Now the 5 factorials will cancel. 10 factorial over 5 factorial is 10 times 9 times 8 times 7 times 6. And once again, 5 factorial over 5 factorial can be canceled. But 10 factorial over 5 factorial, you cannot cancel that 10 over the 5 and make it a 2. Okay, well, similarly, remember 7 factorial over 6 factorial was just equal to 7? Well, 100 factorial over 99 factorial is just 100. 100 factorial could be written like 100 times, and this takes you 99 all the way down to 1, and over 99 factorial, which is 99 all the way down to 1. And now that gets canceled, and that simplifies to 100. How about 50 factorial over 48 factorial? Well, that's just going to be 50 times 49, because the 48 factorial portion is going to cancel. 50 factorial is 50 times 49 all the way down to 1, which I could say 50, 49, and then I could say 48 factorial. All over, and I'll write the 48 factorial way over there. So that cancels, and we get 50 times 49. I'll let you multiply that out. 2250, or no, 2500 minus 50. 2500. Yeah, I think it's 2450. I may be off on that, but 50 times 49 is the answer. 10 factorial over 7 factorial. Well, I've done so many of these, I know what it is. It's 10 times 9 times 8, because 10 factorial is 10 times 9 times 8 times 7 factorial over 7 factorial. And the 7 factorials cancel. That gives us 10 times 9 times 8. We've seen that one before. That's 720. So again, working with fractions that have a factorial in the numerator and denominator is very, very easy. Okay, warm-up question for the next video. In how many ways can 6 people line up at a vending machine? So you've got the vending machine, and then you've got 1, 2, 3, 4, 5, 6 slots. You've got 6 people to line up here. So, how many people could be at the front of the line? 6. How many could be in second place? 5, 4, 3, 2, 1. So in how many ways can 6 people line up at a vending machine? 6 factorial. Because it's 6 times 5 times 4 times 3 times 2 times 1.